everybody. I want to give you a quick video on how to use Pascal's triangle to expand binomials. So let's take a look. First of all, let's talk about what Pascal's triangle is. It's a triangle. Oh, and Pascal, this is the same Pascal that you learned about in your chemistry classes, the same guy, the French guy. He was also really important in the study of probability and in statistics. So those of you who are going on to a statistics class, and especially you crypto guys, you're going to use a lot of probabilities in your work. You'll probably see Pascal and his triangle again. But anyway, here's what it is. It's a triangle. You start up here with a 1, and then you've got 2 more 1s here. And then here's how you get the next row. You have a 1 on the outside. You take those 2 guys and add them together to get 2. And then in the next row, you have a 1 on the outside. You take that 1 and that 2, you add them together to get 3. That 2 and that 1 you add together to get 3. And I think you can see the pattern now. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And the pattern continues. And you can go down just as far as you want. So, what do I mean by expanding a binomial? When I take this is a binomial. It has 2 terms in it. Terms are added. Okay, so the x and the h are added. They're both terms. But that binomial is raised to the 4th power. And I want to multiply that out. Now, I could multiply it by hand. I could use FOIL. It gets pretty messy. But there's another way that I can do this, and that's by using Pascal's triangle. And here's how I'm going to do it. I'm going to start with my x. And I'm going to write x to the 0. Then I'm going to write x to the 1st, x to the 2nd, x cubed, and x to the 4th. Then I'm going to take my h, and I'm going to go the opposite direction. H to the 0, h to the 1st power, h squared, h cubed, and h to the 4th. At this stage, what I want to do is I want to check. My exponents should always add up to 4 in every one of these. So 0 plus 4 is 4, yep. 1 plus 3 is 4, yep. 2 plus 2 is 4, yeah. 3 plus 1 is 4, yep. And 4 plus 0 is 4, yep. Okay, so far so good. Then I come down to the row in Pascal's triangle that has the 4 in it. These are the coefficients in the expansion. So this would be 1 x to the 0, h to the 4th, plus 4 x to the 1st h cubed, plus 6 x squared h squared, plus 4 x cubed h to the 1st, plus 1 x to the 4th h to the 0. And then I would clean this up a little bit. I would write it as h to the 4th plus 4x h cubed plus 6x squared h squared plus 4x cubed h plus x to the 4th. And there I have it. My multiplication I would still probably be working on the x plus h to the 3rd power. And I've already got it finished here. Now, this can get a little bit complicated. I want to show you another example. Okay. And this example is more complicated. You can see instead of having just an x and an h, I've got a 3a instead of just like an h. I've got a 2 instead of just an x. I've got a minus instead of a plus. But the principle stays the same. I start with 2 to the 0. 2 to the 1st, 2 squared, and 2 cubed. And then I take negative 3 cubed. Oh, negative 3a cubed. I'm sorry. Like I said, it can be complicated, but if you're careful, you can do this. Negative 3a cubed, negative 3a squared, negative 3a to the 1st, and negative 3a to the 0. I come here in Pascal's triangle to where I've got my 3. Those are my coefficients. 1 plus a 3 plus a 3 plus a 1. Now, this is pretty messy to clean up, but it's not, it could be worse. So I have 1 times 2 to the 0, that's 1. Negative 3 cubed is negative 27. And then my a cubed. My next term is 3 times 2 to the first, so 3 times 2 is 6. Negative 3 squared is 9. And a squared. And then in the third term, I have 3 times 2 squared is 12. Negative 3 to the first is just negative 3, and then a to the first. And then here I have 8, and negative 3a to the 0 is just 1. And one more step gives me negative 27a cubed. 6 times 9 is 54. A squared. 12 times 3 is 36, so negative 36a plus 8. Bingo, I have it. Okay, I know I went through this really quick. If you have questions, be sure and ask in class, and I'll see you there. Thanks. Bye-bye.